high current open bus, manufacture, testing, installation, and commissioning. Design. The layout of the busbar system, for most of the industries that operate on high current low voltage, is very much standardized. The entire exercise reduces to making the current carrying path as short as is possible. Once that has been achieved, the voltage drop and power loss can be reduced only by increasing the cross-section of the conductor in DC systems. In AC systems, additionally, the skin depth and conductor spacing also need consideration. Optimization can be carried out based on expected life, energy cost, capital cost, amortization. In energy-intensive processes and plants, the contractor is expected to guarantee the energy required to produce a unit of product. A limitation is therefore imposed on the energy consumption of various components. Based on this limit and knowing the route length of the connection, the area of cross-section of the conductor can be arrived at. In most cases, the temperature rise limitation is never a design criterion. Manufacture. Major components of open busbar for high current DC applications are limited to conductors, spacer plates, and laminates. These together form a significant cost of the busbars. Fixings and insulators are bought-out components. Most of the assembly of the components takes place at the site. However, certain sub-assemblies are manufactured at works which can be transported, and are assembled at the site. Sizing the busbars to correct dimensions, machining and drilling for end preparation and welding, form the major fabrication activity. Aluminium. Aluminium busbars for high current applications are manufactured from cast aluminium bars conforming to grade 1350. These are available in maximum cross-sections of 2 feet wide, 6 inches thick and 20 feet long, weighing approximately 2 tons. A custom-built machining facility is required for handling such heavy bars, cutting them to size, milling the surface, and drilling. Metal inert gas welding is extensively used for the fabrication of busbars. Aluminium welding is now an established process. Welders are trained and qualified to undertake specific types of welding. Welding to achieve horizontal and vertical bends and end tabs with aluminium laminates on the busbar is carried out at works. Since good infrastructure for welding, such as a clean atmosphere, jigs and fixtures, reliable good quality of power with least voltage fluctuations, is available at works, it is far easier to achieve a good weld at works than at the site. Copper. Extruded copper bars are available up to a maximum size of 1 foot by 1 inch. The surface of the bars are flat and they do not require any machining. Only cutting, bending, and drilling operations need to be performed. At the site, most of the copper bars are joined only by bolting. Because of the high melting point and thermal conductivity, metal inert gas welding of the bars can be very challenging. The bars will need substantial preheating before welding can be undertaken. Welding is undertaken only under extreme circumstances where bolting is not an option. Flexible laminates are manufactured using the process of resistance welding. This is now a universally adopted practice. Laminates are slit and cut to the desired size, clamped in jigs to the desired profile, and resistance welded at ends. This results in a solid palm. Drilling the palms of the flexibles, as per the bolting schedule, is carried out after the welding process. Testing. Testing of the finished product is limited to the verification of dimensions and quality of welding. Since voltage drop is the most important criterion in the run of the busbars, the voltage drop across the welded joint should be less than that across an equivalent length of plain busbar. Routine testing of all the joints must be carried out at works and the site. Since the cross-section of the welded joint is large, welding is carried out over a large number of passes. Carrying out a dye-penetrant test on the finished welded piece will not be adequate since some of the voids may get embedded within the weld and may not be detected. Installation. Installation is a very important activity since most of the welding is carried out at the site. Prefabricated sections with flexible laminates, along with bought-out components such as insulators, structure, fixings, are dispatched to the site and assembled. High-current open bus bars are heavy and need mechanized contraptions for their installation. Aluminium welding forms the major portion of the installation of bus bars in a metal extraction plant. Copper bus bars with accessories are prefabricated at works and assembled at site with bolting or clamping. The mating surfaces shall be cleaned to remove any oxide layer. It is the practice in the works to provide a protective cover on the mating surfaces, before dispatch, to prevent oxidation. The bolted joints need to be torqued to the recommended value. Aluminium bus bars are welded at the site since it is the most economical and efficient method of jointing. The joint is permanent and need not be maintained. Welding of aluminium, though a well-established process, needs skilled, trained, and certified welders, and a controlled environment and infrastructure. As the voltage rarely exceeds 2 kV, the electrical strength of the insulator is not very challenging. The mechanical properties of the insulators need to be tested mostly for their compressive strength because of the sheer weight of the bus bars. The atmosphere inside the plant is hot, dusty, and corrosive. Porcelain insulators with large creepage distance are preferred since it is far easier to clean them and they are resistant to the ambient atmosphere. Many insulating supports comprise a platform supported by 4 or 6 insulators on the periphery mounted on a common base plate. Linear expansion of bus bars is compensated by mounting them on rollers kept on such platforms. Commissioning. Commissioning of DC open bus bars does not pose a challenge since the voltage levels are very low. It is necessary to monitor the temperature of the conductor joints with an infrared probe for hot spots. Apart from the hot spots on the conductor, open AC bus bars do have to reckon with eddy current losses induced in the metallic structures in the neighborhood. Additionally, hysteresis losses will be induced in the ferrous metallic structures. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to bala@busbarsystems.net.